Okay, good morning everyone. This is Mr.B.Blessed Sam, working in St. Joseph's College of Engineering as an assistant professor. So today, the lecture topic that I'm going to give on the topic called basis path testing. So why particularly this topic I have chosen is, in this real-time world, we use lot of real-time applications. Okay, so every real-time applications is interlinked with both front-end and back-end. So in order to find out the exact things, whatever is happening in the back end or also in the front end, we have to decide which set of statements have to be executed. Okay, so this basis path testing is one of the topic which comes under white box testing. So it is familiar. Everyone know about what is white box testing. So white box testing is nothing but it is a structural or a glass box testing. It is transparent, so the viewers can easily go through the code. Okay, so it is operated everything in a back end side. Okay, so the basis path testing is also called as structural white box testing. So here the developers will intervene into the code and will go out for the entire program and check the certain set of protocols or executor link for the applications to run. So second one, it is used to design test cases which ensures every independent path in a program's control flow is executed once. In contrary to the white box testing, there is another terminology is called black box testing. So black box testing means it is the testing where the tester will try to go on with the flow and check out all the outer paths are executed. So the white box is opposite to that. Here the internal structure of the coding is tested. It means in real-time applications we use a lot of coding practices, C, Python, Java and everything. So the flow of the program is the prior part in the environment. Okay, so to check those control structure of the particular program, we will be using the basis path testing. Okay, so what the second point says is all is used to design test cases which ensures every independent path in a program's control flow is executed once. So what is the independent path? Independent path is nothing but when we are writing certain set of programs or you are writing certain set of algorithms. So we have to find out the thing from the start to the end. Okay, from the head to toe, we are going out to read out the sequence. So from the head to toe, we have to check the conditions, the decisions, the loops, the branches, the path, and also what kind of testing we can deploy into the particular applications. So that's the second point. We have to check out how many independent paths are inside the certain program. So basis path testing deals with various certain type of techniques. So before that, we will be discussing about what is branch coverage. And what is path coverage, and what is statement coverage, and what is condition coverage, and lastly, what is loop testing. So this basis path testing is it's a white box which comes under these terms, this terminology. Okay, so this topic deals with this certain aspects. So these are all interlinked with the particular topic called basis path. So first one is branch coverage, path coverage, statement, condition, and loop testing. So I will be writing out the program in the meantime while I'll be saying out what these terms are all. Okay, so branch coverage deals with the certain conditions branch, whether it's true or it is false. And path coverage means whether all the paths are executed from the head to toe. So it will follow the conditions and whether it is traversing to all the branches and everything is written here in this path coverage. And statement coverage means it is a statement which is executed when the particular condition is true or false. So all the statements are executed. And condition coverage means whether the certain set of protocol is adhering to all the conditions in the given program. And finally, the loop testing. So loop testing deals about if, while, do, if, else, and everything. So similarly, these terms comes under basis path testing. So I will be writing out one particular program and I will explain how we will be calculating the path, independent path, and also how we can derive the graph and everything. So first of all, in this basis path testing, we have to write the code. Any code you can write, okay? And from the code, you have to derive the control flow graph. That's the prior thing you have to follow when you see certain kind of coding. So first one is we have to draw the control flow graph from the given program. So simply draw the CFG. And second one is that you have to find out what are all the possible paths in this graph. Okay, so you have to traverse with all the possible paths. So possible paths. And the third one is you have to calculate the cyclometric complexity. Cyclometric complexity is the particular metric which is used to find out the independent paths. Okay, in the independent paths you will be having edges, nodes, branches, and everything. From that you will be deriving the cyclometric complexity. So that is best thing, cyclometric complexity, best thing to define how many independent paths you can derive out from the program. So V of G. So it is denoted by V of G. So, and from that, how many paths that you have gone through, okay? So how many paths where you have got from the cyclometric complexity as paths, original paths. And fifth one, you have to derive the test cases from the coding. So that's the last part. Okay, so these are all the 5 things you have to follow to find out the basis path testing. So first one is that from the program you have to derive the graph, that is called control flow graph, and from the control flow graph you have to traverse from the head to toe that how many possible paths that you can go through in that graph. And third one is the cyclometric complexity. Cyclometric complexity is nothing but how many independent paths that you can get so far, and fourth one the independent paths that you have arrived, and fifth one is the test cases that you have gone through in the programming. So before writing out the code you have to follow these things, and from the code you have to derive these things. So I will be writing out one sample program. So let's check out for this program the greatest of 3 numbers. So since it's a beginner portion, actually I will be writing out from sample program and one advanced program I will write. So from that we can derive this paths based upon these 5 components. So first of all, you have to write out the standard code for the biggest of 3 numbers. So basic program, so int a comma b comma c, you have to get the 3 numbers and you have to scan. Then you have to check out the conditions for the 3 numbers. So first of all, if condition, so a is greater than b and a is greater than c. Okay, so you have to check these 2 conditions first. Then printf. So if these 2 conditions are satisfied, you have to simply say a is greater. Else if you have to check another one condition, b is greater than c. Printf b is greater, else part printf c is greater. So this is the flow actually for finding out the greatest of 3 numbers. So you have to get the 3 numbers and you have to check out the conditions. So first of all we are checking the 2 conditions and we are using AND operator. So A and A is greater than B and it is greater than C. So if it's so, A is executed, else it goes to check B is greater than C. Then it true, then it will the B is executed, or else C will be greater. So this is the flow, okay, for the program. For this, you have to draw the control flow graph. So before drawing the control flow graph, so you have to list out these things in an order, in a number basis. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so then only you can easily draw the control flow graph. So first of all, int statement. So 1, then it goes to get statement. 2, then it checks the if condition. 3. Then if this condition is true, then it moves to the printf part. Okay, then it goes and check else if condition, that's fifth one. If it is true, then this printf part is executed, and else part 7, and print last part, C is greater. Okay, so this is the control flow graph for this given 3 numbers. So it is easy to draw out. Okay, so first one, second one, and third one. So you have to check the conditions. So this part is 4 and else part is 5. If it is greater, then it moves to printf part 6 and else part and 8. Okay, so this is the sequence to draw the control flow graph. So after driving out all the nodes, you have to connect it with the one more node. You have to connect with a one more extra node. That is called, we are saying V of G equal to E minus N plus 2. Okay, so E defines edges and N defines nodes, and plus 2 means you have to go with the paths, the start path and the end path. So if you have to draw the end path, you have to connect with one more node. So that is called 9. And you have to connect the remaining nodes in the graph. Okay, so now you have to check out what are the possible paths in this given graph. So first path is 1, 2, 3, 4, and 9. And second path is 1, 2, 3, 5, 7, 8, and 9. And another one path is 1, 2, 3, 5, 6, and 9. So these are the 3 paths that you can get so far if you draw this graph. Okay, so first path is 1, 2, 3, 4, and 9. And second path is 1, 2, 3, 5, 7, 8, and 9. And last part is 1, 2, 3, 5, 6, and 9. So now you have to determine how many possible paths. So the possible path that you have got is 3 from this program. Now you have to derive what is cyclometric complexity. So cyclometric complexity is basically used to determine the number of the independent paths. So the independent paths is determined from this graph where it contains edges, nodes. Okay, so edges defines this one: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the edges which are interlinked between each and every nodes. So 10. And how many nodes? So the nodes that you have got is 9. So 10 minus 9 plus 2. So 1 plus 2 is 3. So you have went for the possible path as 3 and also the cyclometric complexity as 3. So this first 3 things have been satisfied, and now you have to go with the test cases. So before going with the test cases, you have to cross check whether the cyclometric complexity is true or not. For that, you have to follow another 2 aspects. First one is that you have to go with the boundary conditions. Okay, so if you are simply writing the program and checking out what are the paths, it is not at all. So the boundary conditions are required to satisfy whether each branch is executed once, whether each condition is executed once, whether all loops are traversed once. So for that, you have to follow another one called boundary regions. So V of G is equal to number of boundaries plus 1. So you have to follow the number of boundaries. So here you have got 2 boundaries which is enclosed between this graph. So 1 and 2 enclose the regions you have to follow. So the number of enclosed regions is 2, and you have to add 1 outgoing region. So 1 outgoing region you have to add. That is 2 plus 1 is 3. And after that, you have to derive how many predicate nodes. So predicate nodes means nothing but if you're having more than one outgoing region in this graph, then it is considered as a predicate node. So predicate node is P plus 2. Okay, so you have to follow how many, is there any one additional edge in this node. So 3 have 2 outgoing edges, so you have to consider this one, and 5, 2 outgoing edges. Okay, so totally you have 2 outgoing edges in this graph, 3 and 5. There is no another outgoing edge in any kind of this node. So 3 and 5 has 2 outgoing edge. So the predicate node is 2 plus 1. So now you have derived the predicate node value as 3. Okay, so you have derived the possible paths as 3, cyclometric complexity as 3, and the original path as 3, and now you have to go with how many test cases. So the test cases are this condition, if condition, else if condition, and else. So totally 3 test cases. So the first condition is you are using AND operator and check 2 conditions, and else if part 1 condition and else part another conditions. So you have to traverse with all the conditions and you have to derive how many test cases that you are arrived. So if, else if, and else. So it is a multi-decision boundary statement. So you will be using 3 test cases. So test cases that you got is 3. Okay, so this condition, and this condition. So now let's see for another one program, and we can derive all this path. This is basic general program for the greatest of 3 numbers. We can use another one program so that it will be easy for you to gain more knowledge about this path testing. Okay, it's a simple program, only 4 lines of code, and from that we can derive the CFG, independent paths, and test cases. So if A is equal to 300, okay, so this is very basic code actually. So from that you have to derive this CFG. So before that you have to count the statements, count the sequence, how many lines of code are there. So 1, 2, 3, 4, 5, 6, and 7. So totally there are 7 lines of code. Okay, so now this code is very easy. So first of all, if condition. So if A is 300, so if the condition A is 300, okay, if it is true, then this inner loop gets executed. If it is false, it goes for this end of and it prints this. Okay, so if the condition is true, then it goes and check for second one, B is greater than C. Suppose B value is 20 and C value is 10. Okay, so then if condition B is greater than C. So yes, the condition is true. Now the A value is assigned. Okay, so B value is 20. Okay, so here this operator, this B is directly shifted for the value of A. Okay, so A value is now 20, and if this condition is not, if B value is 10 and C value is 20, then you have to go with this condition, A equal to C. So B is equal to 10, C is equal to 20. So if this condition is not true, then you have to switch over for this one. So A equal to C. So similarly, you will get the value as 20. Okay, the A value. Okay, so if you go with this value, this assignment operator will assign the values that whatever you get in this one, and it will end the statement, and final statement will be the 20. The answer 20 will be printed. if it is false in this first condition, it goes for the end of that as outer loop and it executes print A as 300. Okay, for this you have to draw out the CFG. Okay, simple. I will be doing the things very fast. So now you have to go with the lines. So first line, and then if condition, then if B is greater than C. Okay, then this condition, else this condition, and if and seventh one. Okay, so if this condition is false, it directly goes with this statement. So okay, it jumps to this part. So now you have to draw the control flow graph, derive the cyclometry complexity and everything. So count the number of edges and the number of nodes in this graph. 1, 2, 3, 4, 5, 6, 7 edges plus 2. Okay. So V of G is equal to E minus N plus 2. Okay. And now you have to check out how many enclosed regions are there. So 1 and another one. So totally 2 enclosed regions. Anything? The pass panna babu. எவ்வளவு வந்திருக்கு?